Hello, everyone, and welcome to lesson 10-2, which is on more multiplication properties of exponents. So underline. So you have hopefully done 10-1, and that gives you an idea what's a power and an exponent is. So the objective is to raise a power to a power. And in this case, when you see parentheses, this is the rule to raise a product to a power. So the rule is, we're going to write it right here, to raise a power. Remember, a power is something that looks like this, x to the power of 7. That's a power. This is your base. This is your exponent. It tells you you multiply this thing together 7 times. Just to 1, 2, 3, 4, 5, 6, 7. Just to give you a review, this is the power. To raise a power, what did I want to say? To raise a power to another power. So now it's twice. And here's the clue, you multiply the exponent. In the previous lesson, we had to add them. Today, in this lesson, you multiply the exponents. So the key word is multiply. So here's an example. I said that usually you see parentheses. Let's say you have x to the third raised to the power of 4. So this is what it would look like. You have an exponent and a base in parentheses, and you're raising all that to another power. And this would mean it's x 3 times 4 is x to the 12th. This would be the answer. So you multiply these two. And here's on the bottom of the page, it's an explanation why that works. And it's called repeated multiplication. Okay, well, what is it showing here? Oh, so you have x to the power of 5, and all of that is squared. So you have x to the power of 5 times x to the power of 5, because remember, the power here tells you how often to multiply the base. Now this is the base. Yeah, and the base is x to the 5. And you would add these exponents because you're multiplying 2 powers, and that would be x to the 10. 5 times 2 is 10. Okay, so that kind of gives you an explanation. Down here, you're using algebra. First, the words to raise a power to a power, multiply the exponents. We already have it above. This is the algebra version. You use letters. A power raised to another power is the base times m to the power of m times n. So this is kind of the algebra version. And here it gives you more examples. And I skipped the fraction exponents too in depth. I want to move on. And so we're using only whole numbers, okay? So the next page, by the way, we're on page 607. The next page has simple examples. And what is the simplified form of each expression? Multiply. You notice you only have one base, p. 5 times 4 is p to the 20th. Make sure you write these numbers higher. The exponent has to be higher than the base. Okay, this one is the same way. You only have one base. 4 times 5 is also 20. Skip that one. And skip that one. And over here it says, should you add or multiply? That's the question. You're going to have trouble with that. Should you add them or multiply the exponents to simplify each expression? In this case, it's multiply. Why? Because you are raising a power which is in the parentheses, p to the 5th, to another power, which is 4. I won't put that in parentheses because you'll be confused. Why is it in parentheses? And I wanted to talk about which one is more important. The outside one is where you will start looking. This is the power you're raising it to. This is the inside of the parentheses. So the outside one is really more important. And we'll maybe come to an example later. I think that's it on this page. So we're moving on. Page 608. It says use the order of operations when you simplify an exponential expression. So the order of operations is called parentheses first, exponent second, multiply and divide. These two are equally important. You do them from left to right, whichever comes first. Add and subtract are last. Same with these two. These are equally important. You do them from left to right, whichever comes first, okay? What are the simplified form of each expression? Oh, my goodness, there's a lot of things going on. We're going to do the parentheses first. See how it starts with parentheses? So I'm going to do this part first. So the first part I'll leave alone. It's a times. These are all times, okay? Everything is pretty much either multiplying or dividing. 6 times -4. It's x squared. 6 times -4 times x to the power of -24. Notice we have same bases and we're multiplying. So we now add exponents. So first we multiply, then we add it. So we have x2 plus -24 is 2 plus -24 is -22. And if I want to make it a positive exponent, I have to write it under 1. This looks better than this, okay? This has a fraction, I won't do that. Where am I going next? That's it on this page. I want to just give you a little clue about fractions. Let's say I have, let me make one up. See how these exponents are fractions? This is just a sidebar. You don't have to worry about it. If you have a fractional exponent, 16 to the power of 1/2. The bottom number tells you this is a square root of 16. So that's what a fractional exponent is. If this is a different number, let's say this is a 3, you have the square root, because this is a 2 here, of 16 cubed, which makes it 4 cubed, which makes it 64. So that's the trick about these these fractional exponent. Don't worry, I won't test you on it. I'm not even going into it very much. Just if you ever see it and you're interested, when you have a fraction, it's really a root, either a square root or a cube root. We also have cube roots, etc. Okay. We also have fourth root. We have infinite many roots, actually. But please don't get sidetracked. You know, there's some of you who like that stuff. And this is, what do we have on this page? I think I left the top pretty much out. But here, what is the simplified? Look at the base. The base is everything in the parentheses. This is your base. Okay, so the parentheses tell you all of that is raised to the 3rd power. The parentheses make a difference. So what we're going to do is what's called shower the power. So shower, you go to the outside. The outside is where it's important. Like a shower, right? Showering, shower the power on the outside. So now we have 7 raised to the power of 3 times, remember I said it's always times in this lesson, m, and you multiply these two, 9 times 3. 9 times 3, 27. 7 cubed, I believe, is 7 times 7 times 7, which is 343, m to the power of 27. Okay. So you shower the power, however many are in the parentheses, each one gets that power of 3. What is implied? What is the implied exponent of the constant 7? It's also a power of 3. Okay, shower the power. Okay, let's see if we find some more. This one has a negative exponent. Should we distribute it first? No, I'm going to make it positive first by putting it under 1. My base is the 2z, and I always like to put a bar through z to the power of positive 4. Yeah, that's how, remember how we make negative exponents positive. So I'm using this part right here and make it a positive 4. And then, so am I on? Pause recording. Okay, and then we're going to do the shower the power on the bottom. So the top stays, but the 2 gets a power of 4 and the c gets a power of 4. So keep the 1, 2 to the power of 4 times z to the power of, there's a 1. If there's no power, you put a 1. 1 times 4 is 4. And you can simplify that a little more because 2 to the power of 4 is 2 times 2 times 2 times 2, which is 4 times 4, it's 16. C to the power of 4. That would be the best way to show that. Okay, next one. Shower the first, let's make the 2 positive, putting it under 1. Positive 2, the negative becomes positive. Shower the power. But only if it's parentheses. If there are no parentheses, don't do that. 3 squared is 9, g to the 8th, because you're multiplying these two powers. All right. Okay, what else do we have? Nothing on this page. Let's move over. We're, by the way, on page 609. 610. I'm skipping to problem 4. Simplifying an expression with products. See, this is the product. This times this. Okay, what is the simplified form? You definitely don't want all these parentheses. Let's start with the first part right here. I'm starting here. I'm showering. Nope, that's just one expression. So I'm going to multiply it out first, even so this is a negative exponent. So I have x negative 2 times 2 is to the power of negative 4 times, there's our times button. Now I'm doing this part. But I will shower the power because I got more parts. I got 3 parts in here. Each part gets a power of 4. X to the power of, still remember this is a 1. 1 times 4 is 4. Y to the 20th. Can I combine anything? First of all, this I'm putting to the bottom. Make it a positive 4. This is gone then. It's now on the bottom. The x to the 4 cancels out. because it's the same thing. If it's the very same thing and you're multiplying, this only works, canceling only works with multiplication problems, by the way, but if it's the very same thing, cross them out. And now you have 3 to the power of 4, y to the 20th. 3 to the power of 4, I believe, is 81. 3 times 3, 9. Yep. Y to the 20th. Okay. And on the bottom, C. Okay, I start with the first part. This is the product. This times this. There's a little times button that you don't see. So I'm going to start here. I'll shower the power. It's got 3 parts. 6 cubed times A cubed times B cubed. This one, leave the negative exponent for right now, times 5 squared, A to the power of -6. -3 times 2 is -6. 6 cubed, 6 times 6 times 6, 36 times 6 is 216. I'm going to make that number red because it's what's called a coefficient. I'm going to, these are A cubed times same base. You notice the A's have the same base. I can add the exponents, which is A to the -3rd. So I combined the A's. The B doesn't have a partner. This is 25. 5 squared is 25. The red numbers are coefficients. I multiply them. 216 times 25. Use a calculator. It's 5,400. So these two are dealt with. Now I have A to the 3rd. That goes on the bottom. Make it a positive times the B cubed stays on top because it has a positive exponent. So the answer looks like that. Let's go to the next page, page 611, and we're going to look at this box in the middle. And it says, you can use the property of raising a product to a power to solve problems involving scientific notation. Here it comes again. For example, to simplify the expression 3 times 10 to the power of 8, all of that raised to the 2nd power. See how that 2nd power is on the outside of the parentheses? It's raising a power to another power. You need to multiply the exponent, but you need to also shower your power. You raise both 3 and 10 to the 8 to the 2nd power. Then multiply the 2 powers. Let's try that. So I have 3 times 10 to the power of 8, all of that raised to the 2nd power. So you have to shower the power. 3 squared times 10 to what power? 8 times 2 is 16, and 3 squared is 9. When those numbers are small enough, you can simplify them. If they get too big, don't. Ten to the power of 16. So that's what that would look like. Okay. All right. So on this page, I'm doing the bottom. Simplify, write your answer in scientific notation. Use a calculator. So we have our scientific notation. Whoa. raised to the power of -2. So you can do two things. You can make the power of -2 positive right away, or you can just do shower the power and then finish fixing it at the end. So that's what I did. I chose 2. Come on. I chose to just multiply. So you have 6. Oh, my machine is cracking up here. 6.25 raised to the power of -2, right? Times 10, base is 10, -12 times -2 is positive 24. Okay, I saw that I'm going to have a positive exponent, so I decided to just multiply it out instead of putting it all under 1. Okay, but now I have to deal with this. This is 1 over. There's several ways to do this, guys. This is a really small number. Remember, scientific notation starts with something like 5.1 times blah, blah, blah. It's like, I'm just going to make up a number. It has to look like that in the beginning, not like that. This is not good. So I'm going to continue. I'm going to plow away. 6.25 times 6.25 is 39.0625 times 10 to the power of 24. And I'm going to divide that. So you use your calculator. You go 1 divided by 39.0625. I'll put that over here. $39.0625 equals, and you'll find you'll have a number that says 0.0256 times 10 to the power of 24. So we went from here to here. This is sidebar. This is just side work, right? Showing you how it works. And remember, we want our decimal to look like that. So I have to move my decimal over 1, 2 spaces. When I do that, I have to adjust this number. I'm moving it to the right, so I'm going to adjust it and take away 2. So now my number looks like this, 2.56 times 10 to the power of 22. Whew, that's it, scientific notation. Really tricky, okay? And then we have, I believe that's this page. And then we have the homework. So we're starting with number 11 and number 12, 15 and 16. Remember, shower the power. Okay, because it's in parentheses. And then 17 is an error. See what the error is. And oh yeah, 18 is the error and 17 is just know how to understand the vocabulary. That's super important in math. If you know what the words mean or what the question means, half the battle. Here you have to fill in all those blanks again. B squared to what power is b to the 8? 2 times what is 8? I believe it's 4. 2 times 4 is 8. So you fill in the blanks for 20, 23, 26, 27, 22, 28, and also I'm giving you 29. The volume is the length, because these are squares. Small cube, it's a cube. A cube has all equal sides. So 6, 6, 6. And the volume is the length times the width times the height. So this times this times this. this times this times this. So you're comparing how much bigger is this volume than this volume, okay? And then on the next page, there's one word problem. It's problem 43, the geography problem. So notice there's a lot of scientific notation. The radius from the Earth is from the center to the outside. This is your radius. What is the approximate surface area of the Earth? So this is the radius. So you're squaring your radius. So you're squaring this. Yeah, remember, shower the power. Leave your pi, leave your 4. Write your answer in scientific notation. So the 4 pi is really, you can leave that, or you can use 3.14 for pi. Okay, or pi is actually on your calculator. It's a key and it's very exact. So you can use that. All right, and then it says oceans cover about 70% of the surface. About how many square meters of Earth's surface are covered by ocean water? Ooh, you have to find 70% of your surface area. So you multiply the surface area by 0.7. That's 70%. The oceans have an average depth of 3,790 meters. Estimate the volume. Oh my goodness. Volume is always three-dimensional. You need like something that goes into depth. So if this is the ocean, you always multiply this times this number times this number. Well, I'm sure that you guys might be struggling with this, maybe not, hopefully not, but try your best, okay?